Okay, let's do it. Enum and pattern matching. We're at chapter 6 of the book. So yeah, it's been very productive weekend. I've spent a lot of time this weekend learning Rust, and it's been nice so far. Yeah, I hope to. So the plan is to get through the book and then maybe do some wrestling exercise, and then maybe later then we can find some projects to work on. Maybe some open source project, I don't know. That would be fun. I don't know how well I will be after doing all this, so let's do all this first, and then we can evaluate whether we are good enough to maybe find some very simple issues and to work on. That would be great. So yeah, look at enumeration, so enums. Yeah, so Rust have enum. Define and use enum to show a enum. Particularly useful enum call option. Ooh. Express a value that can be either something or nothing. And we can use pattern matching with it. So use match. And finally, we cover how if let construct is another convenient. Ooh, it's gonna be a lot to learn in this chapter. Let's go. So we have learned struct in this morning for me, in the last stream. So yeah, so we have tried to use rectangle, and so we can also have a similar idea. We have circle and triangle. We may want to express in code and see how enum are useful. More appropriate than struct. So sometimes we use struct, sometimes we use enum. Two major standards are used for IP address. So version 4 and 6. So v4 or v6 for IP address. Okay. I don't know too much about IP address, but I don't think you need to be an expert to understand this part, so it's fine. So we have an enum IP address kind, so which kind of IP address standard we're using, v4 or v6. So enum value, so 4 equals to IP address kind, v4, 6 equals to IP address kind, v6. So it's kind of using the colon here. And so for example, we have root and we take a IP address kind. That it's what it is, and we can add call this function with either variance. Okay, so using enum has even more advantage. Think more about our IP address type. At the moment, we don't have a way to store the actual IP address data. Only know what kind that is. Just learn about struct, so we can now create an IP address struct. So the kind will be one of the kind, and address is a string. So this is how you kind of declare an IP address, like that. So basically, so you can take either v4 or v6 as the kind, right? Yeah. Okay. Yeah, I think that's the advantage, right? You can just say that the kind need to be one of these, so it can be either v4 or v6. This is super similar to my previous work with Terminus DB. We also have to deal with a lot of data structure that is similar to that. We have enum, we have struct, and it's not surprising that a lot of my colleagues using Rust. So yeah, and yeah, so we have v4. So now we're adding stuff to it, right? We're adding stuff to it. So this is how we do, but we can make it more simple. Doing the work first is home. Yeah, but if we do it like that, represent the same construct, just an enum is more concise rather than enum inside a struct. We can do it the other way around. We can have a enum IP address and then v4 and v6, so each of them is taking associate a string value to it. So we can do it like that. v4 string and just put it a string. So each one of these is actually, you can have a string value attached to it. So it's kind of being more concise than this. So instead of having kind and address, you can just have a kind as a enum type, and then you have a string attached to it. So it's even more concise than before. Or because address are like this for v4, I think this is what I am most familiar with. So you can actually just take 4 numbers, right? So it's like, so UH. This 0 to 1 to 7. So UH is enough. Just put it like that. Yeah. No, actually, like, yeah, for this 4 thing is like 0 to 2 to 5 or something like that, I think. So yeah, this U8 will be enough for this 4 numbers. So you can do it like that as well. So it doesn't need to be a string. It could be a tuple that store 4 UH values. Yeah, it's between 0 and 255. So UH is gonna be enough, and it's perfect for that. Any kind of data inside enum variant string, anything that could do. Use our own definition without conflict, because we haven't bought the standard library's definition into our scope. Yeah, it could get complicated in chapter 7. But let's look at another example. So I have a enum message. So message can be either a quit message, a move message, a write message, or a change color message. So each one of them could have different things attached to it. For example, move is a struct actually. So it's kind of like a union of different types actually. Or is it a union? So it could be any of these type, right? It could be a a tuple with like 3 numbers, or a string, or a struct. So yeah, it's like a struct. So move is like a struct. It got name fields, and quit has no data associated with it, and write has a string, and change color had 3 I32 values. So Ian doesn't use the struct keyword. Yeah, they're all grouped together under the message type. So so move message. Hello, there's a comment. A tag unit and work in C. That's how it works. Yes. Thank you. Yeah, this is yeah, I don't know a lot about C, but Python have similar thing as well. You can have different, like we have a generic type that's like you can have different type, and then you can combine them and create another type. It's kind of like that. I think a lot of like the recent years of like the Python, the new Python thing that got added in in Python is kind of, a lot of them are very similar. I think because a lot of Pythonistas are also learning Rust, and we kind of like seeing, oh, this is useful, maybe we should have it in Python as well. So got added to Python. So yeah, this is super cool. Enum, I like it. So if we don't do this enum, we can actually define 4 structs. The running structure would hold the same data that the enum variant holds. So you can create 4 struct. But then when you pass, but you can't say like, oh, there's the type that's called messenger, right? Message, right? So you have to make them separate. If you use different struct, has its own type, then you can't really have a very easy way of saying like, oh, it could be any one of those, which is the message, Most similarity between enum and struct is using the impel. How do you call this? So you can also associate methods function to it. So now I have a method call, and yeah, so it's associated with message. So now it's like I think each one of these would also have a call because it's associated with message. So message write string from hello. So then since M is a write instance, so a write instance is one of the message instance, so it will also have a call. So it's kind of like a subclass, right? Implementation, yeah. So it's the first 4 letter of implementation. So imp, I guess. imp. Yes, implementation. Yeah, implementation. Well, or maybe I should say implementation. I don't know. Yeah. Cool. So yeah, so every one of them would have a call method. Another enum. Standard library is very commonly used as option. So this is one of the enum that got used a lot of times. But it's included, so it's in the standard library. Advantage over no value. So what is option? Case study of options, another enum defined by standard library. Common scenarios. First item in a non-empty list, you will get a value. If you request the first item in an empty list, then you will get nothing. So expressing the concept in terms of type system means that the compiler can check whether you handle all the cases. So so sometimes things would end up having multiple results. So then you may have to use option to handle all of the possible results. So that's also another very robust thing in Rust, that you can't just let it slide. In Python you can let it slide, you can accept and woo. But in Rust, no, you need to handle all of the possible outcomes. Programming is often thought of in terms of the feature you include, but the feature you exclude are important too. Rust doesn't have the null feature that many other languages have. Null is a value, that means there's no value. In languages with null, variable can always be in one or two state, null or non-null. So it could be something or nothing. Yeah, this is cool. $1 billion mistake. Ooh. Okay. So that. Yeah, so it's now a mistake. I don't know. I don't think I am knowledgeable enough to decide, but in Rust, there's no null. We have to handle it. Try to use a null value as a non-null value. Yeah, I got a lot of errors, like during my Python times when I write Python code, then a lot of time there's an error because I'm not expecting a null, but I got a null, and then all kind of crazy thing happened, right? It's like, oh, I expect it would be something, and I try to call something or point it, but then like you get an error that like, oh, you don't have that method, and then later you realize, oh, that thing become a none. That's why like none doesn't have that method. Of course, then it just like got derailed. Your program got derailed, and then but sometimes it's difficult to find because I just get an error that like, oh, you don't have this method or something weird, but then you end up because you're expecting something to be non-null, and it's like something to have an actual thing, but it's a none in Python, then it just go crazy, right? So if you forget to check that, if you're just like overseeing and think it's a given, then yeah, you get all sorts of error. But I think in Rust, this will happen less because you have to handle all cases. Now it's sometimes still useful. You just say something is invalid or absent for some reason. So that's why you get none or null everywhere a lot of times. But if you don't handle it properly, that's the problem. So why now is a mistake and why now come into existence? I think I should look it up when I have time, but I don't want to get this too distracted here. I should look at it after. I will look at it after. Problem isn't really with the concept. So what should we do? So an enum that can encode the concept of a value being present or absent. That's why option come in, defined by the standard library. So this is the definition of option here. There's none or something. The T, I think, is the type, right? included in the prelude. I think we have used it before, but we forgot. Yeah. You don't have to bring it to scope. So it is included so you can use some and none directly without the option. Ooh. So this is so important that you don't even need to call it in. It's just if you type none or some, then it's there. Option enum is just a regular enum. Some T and none are variants of the type of option. So T, this T syntax is a feature of Rust that we haven't talked about yet. It's a generic type, and it will cover the generics. We'll learn in chapter 10. Some variants of option enum can hold one piece of data of any type. Yep. Each concrete type. Let's see some example. Otherwise, it's very difficult to understand. So some 5 is some number, some character, some E, and then absent number. Okay, so the type of some number is some number here is because it's just a number and default is I32. The type, so this one will be option character. Absent number, then we have to say the type, right? We have to say that is I32. Requires to annotate the option type. Can infer the type that is the corresponding sum variant we hold by looking only at a none value. Yeah, I think you can just say it's none because it could be anything, right? It's none, but like what's the counterpart of that? Then you have to say, oh, it's either there's like some number or it's like some number 5 or it's none that is in this type. Because like it needs to be belongs here, right? So okay, yeah, otherwise the compiler doesn't know which this none belongs to, right? Some value, we know that value is present and the value is held within the sum of a none value. Same thing as no, we don't have a valid value. It's better than having just no. So at least we know something about this none, right? If it's present, then it to be a number, I32 number. And T, where T can be any type, are different types. The compiler won't let us use option T value as if it was fine as a valid value. It's trying to add IH to option. So this is Y is some 5, but this is a I5, then this is IH. So these two are two different type actually, because X is IH, but Y is option IH. Definitely a valid value, for example. How to add IH and an option IH, because they're different types technically, even though you can say, well, if you look at option IH, if it's like not missing, that it's just a number, right? It's just 5 and 5, but no, Rust will treat them as different types, so you can add them together. So IH it can't be none because it's not option IH. So IH must have a valid value. So it doesn't check for now, but option IH, it could possibly have a missing value. So that's why it got handled differently, and then we can just add them together straightforwardly. So you have to convert a option type into the type before you can perform a type operation with it. This have one more common issue of null. So you have to make sure that it's not null before you can do the. For example, if so imagine this Python, right? Like, oh, it's an integer and it's an integer, but like is, well, I mean, like, now it's not an integer, but like, let's say you just add an integer with now, and then but you're expecting it to be an integer, it's not now, then well, then some would have a problem if y is somehow to be null. But because in Rust you have to make sure everything is clearly labeled. For example, this can't be missing, this could be missing, but when you add them together you have to change this into ih, which need to check whether it's missing before you can add them together. Yeah, so this is how Rust work, and it may sound very tedious at the beginning, but I think they do it to, yeah, again, to make sure that your code is mistake proof. So yeah, I know it's like very scary for beginners, but maybe we'll get used to it, we'll see. That's what the fun part come in. Like, there's so much rule that you have to follow, but it's like having a very like awful tasting medicine, but it's for your own good kind of thing. Yeah. Right, so we were here. Get t value out of some variant, then you have a value of the type. Yeah, so how do we convert it? How can we convert between the two? Yeah, eliminate the risk of incorrect. This is the design that is like for your own good. So you should be more robust in labeling things and make sure the type matches. Yeah, how to get the t value out of the variant. So you have to use some method out of it. Yeah, it's very tedious starting out. I can see that. It's already sounds a bit scary. Yeah, there's some tools. So for example, it said that you can use some method to extract the value out of it. It's in the documentation, but we are not looking at it first, because I think I want to go through the chapter first. But let's have a peek. Let's have a peek of what's saying. Yeah. So there are a lot of is some and is none. So I guess you can check if it's none as reference, as mu, so you can maybe convert it back to something. And yeah, there's a lot of method that you can do things with. I guess we would refer to it when we need to do something. And it's in the next chapter, so we gotta be patient about it, and we'll wait to see. To use option t value, we have some code that will handle each variant. So yeah, we use the match expression to do it, so we would be fine. Don't worry, we will be fine. Let's go. So we'll see how we can handle that, right? We'll use the match and see how it goes. So how to use the match control flow with all the things that we have learned. Yeah, this is pattern matching. So I have to confess, when Python 3.8 or no 3.10 introduced pattern matching, then like I was like, oh, why do we need that? We have been using even if and else if and else is like using it very well. Why do we need that? But then like I guess just recently I see, oh, actually they could simplify a lot of things that I do in the past. I have to like, strip down a lot of things. For example, check if I have a something like a struct that have like a nested structure, I have to check each one of them. It could get very tedious. So I guess like pattern matching, using match in Rust is also very useful here. So we have an example. We have the coins. We have penny, nickel, dime, quarter. So yeah, there's a we would dive more into it in chapter 18, but we're not going to do it now. We're just going to look at this example and see what we learn now. So we have a function, we have coin, we will take any coin, so we'll match coin. So each one of these will have a different handle cases. So if it's penny is 1 cent, nickel is 5 cents, dime is 10 cents, and quarter is 25 cents. So yep, so it got handled very gracefully, I guess, here. And we also use this operator, I think we have seen it before. Now it's just a recap and explain what it actually does. And let's see. Curly. Also, if you have more than one thing, then you have to use the curly brackets. So that's another scope. At the end, it will return 1, but it will also print our lucky penny. Okay. Yeah. And then yeah, so I think this match, it will return any value here, right? So and then it will return to the function, so it will return the value of the coin. Yep, except that one will also print out lucky penny. Pattern that binds to values. So are we still looking at coins? Okay, yeah, we are. We're USD, so there's different stay have different thing. Stay value store inside. Okay. Now we have a different state, and then we have different coins, but each quarter we would have a state attached to it. Yeah, so because they have different designs depending on the stay, so we have to attach it to. So attach an enum to an enum. Cool. So when we match the pattern, we can match it. So this, so we can also have the state inside. Then the state will return the thing that got matched. So it will be any of these states, and then it would return, and then we can actually print it out. That's really cool. So when the match, so this is exactly like how like the Python pattern matching work, right? I think Python like borrowed the idea from here, or maybe I was wrong. I don't know, or maybe Great Mind thinks similar. Yeah. So it will also return the value of the state. Like if it matched, then it will match up the value of the state, and then it will become the value of the state in this one of these states, US states that we have. Yeah. So, for example, we have a coin, there's quarter, and then we have one of the state, Alaska. Then it will, so state will be US state, Alaska. So then we can print it out. Yeah. Can I run this? Will it work? Oh wait, not work. Yeah, from Alaska. Yoo-hoo! So that's really cool. Okay, so now we see how the option we can handle all cases. So we use match. So if it's none, then it's none. If it's some value, then we add 1 to it. So, so this is how we do a +1 with this case. Yeah. Yeah. So because x is the option I32, so it could be nothing or some value of I. Which is like, you know, a number, and then we can add 1 to it if it's none, then we handle the none. The none just give none. If it's not none, then we add 1 to it. Right. So +1, so 5 is this, +1 5, and then so if it's none, so you can +1 none, then this one should be none, right? Okay. I guess this one needs to be I32, but this none can be any none, right? Like it still works, but no output. Okay. Interesting. We match. It matches. No value add to. So it does it. Yeah, it returns the option I32. So everything is working as I32. I guess the default is option I32 for none here, I guess. Or maybe it's not. I don't know. Or maybe because we have the +1 here, then it's option I32. Yeah. Yeah, I'm quite surprised that you don't have to kind of make sure this none is a I32. But it's it kind of worked, I guess. The compiler just guessed it. It's very useful. So let's see other aspect of match. So there's another way. Oh, this one got a problem here. What's going on? Oh, because we haven't handled the none case, and it's not allowed. You have to handle all the cases if you have matches. Yeah. This code we caught a bug. If it's none, then it's a bug. Yep, so it got catched by the compiler, so it needs to be exhaustive. So matches need to handle all the cases. If we're missing one, you can't. Yeah. I think this is very good as well. Make sure that it works. Catch-all pattern and the placeholder. So, and then you take special action. We have a dice roll. The full type of this none is yeah, if it doesn't infer the exact type, then it was, I guess, because we put a none in the +1 here and it take a I32, that's why the compiler kind of know that this is I32, and it kind of works if it's I30, like option I32. If it's not, then you know, the compiler will also like give you this error, or yeah, you just won't have a good time. So yeah, it needs to be deterministic, I guess. No ambiguity. If the compiler doesn't know, then you would have a trouble. You have to solve it before you can compile the code. So we have a dice roll is 9, and if the dice roll is 3, then add fancy head. If it's 7, remove fancy head. If others, then move players. Right? Okay, so how to do the other thing, right? Like, so we have other. We have a so this one will work. We have the other for the other options that is not 3 or 7. It's out of scope. Okay. Yeah, so to ignore this, but this just show that we can use other to catch the rest. Okay. Yeah, it compiles. Last pattern will match all the values not specifically listed. So it needs to be last, so it's like else, isn't it, if it last? To catch all the rest of it. Yeah, so our others will you know, store the value. So if it's not 3 or 7, if it's anything, then other will have the value and then put into it, right? But if we don't need to use it, then we use the underscore, which means that we don't care. Reroll. Yeah. Okay. Yep. What is this? Yep, so this will, yeah, this will be anything, but if it's underscore, then we don't care, so we just put it away. Okay. So if it's nothing happen, you can just use the empty tuple type. Okay, so yeah, if nothing happened, we don't care what it is, it's just nothing happened. Yep, like that. And then we tell us explicitly that we aren't going to do anything if it doesn't match 3 or 7. If any other thing, nothing happened. Ooh. Okay, so now we're going to move on. So, like, again, all of these will get complicated in the further chapters, but so far we just learned the basic, just not to be like blow our mind and we go crazy. So we are going to learn if let syntax. then it will also be very handy if we use it together with match. So let's see. And if let, syntax lets you combine if and let, the less robust way to handle values that match one pattern or ignore the rest. Okay, so for example, we have config max, we have free u8 here, some free u8, and then yeah, so some max will print maximum configuration to be max, and others is nothing. So if the value is sum, we print out the value in sum variant by binding the values to the variable max. So for example, if we have 3UH, I guess is like 3UH will be here, and then do anything. So if it's none, you just do nothing. Okay, so we add this. Boilerplate codes to add. So for example, if do this, then we would get 3, right? Because this 3U8 and then it's got here and then it will become 3. And so, okay. Instead, we could write this in a shorter way, using if let. Because what happened is that, so if it matches, then we have this max here, right? But we can, so if it's none, then we do nothing, but we can actually write it simpler like this. So using if let, so it's the same result, but now we don't have to write the two branches out. Yeah, so if it if it matches, then it would just have the max here. For me, this is very confusing because this two doesn't look exactly the same. But I have to like kind of tear it down. See, take a pattern and an expression separated by an unequal sign. So this is a pattern. Works the same way as match. So instead of match, right? So we have this one where the expression is given to the match. The pattern is its first arm in this case. This pattern is sum max, and the max binds the value inside the sum. You can then use max in a body of the block the same way. If some run if the value doesn't match. So if this doesn't match, then I guess this doesn't happen. Syntactic sugar for match that run code when the value matches one pattern and then ignore the others. So if you have only one thing that matches, then you can use if let instead of a match. Let's see. Yeah, so if let is a syntactic sugar. So it's if you have more than one matches that you care, then ignore if let. But if you only have one thing that you care and the other just nothing happened, then you can use if let. So only if it hit, then something happened. So you if let here like this. I think it will take me some time to get used to this. This looks a little bit like, yeah, maybe if I seen a tons of them in the code, then I will be like, oh, okay, I know what's going on. But yeah, it takes some time to get used to. So it's a match that only have one value that counts. Right. You can also include an else with an if let. So if it matches this, so we have the state and we can the state, else is just count in, +1. Yeah. Checking that matches and force. Yeah. So yeah, it's like the empty case. then you do, if you do something instead of doing nothing, then you can use else, right? Okay. Yeah, I think again, like, it would take me some time to get used to. I may not use it very for error handling, yes. So I guess I'm sure I will see tons of them in the future. But I think at the beginning for me it would be a little bit like with like mind twisting. That is like, what's going on? Okay, one step back is a match, and then okay, yeah. Ooh, blew my mind. It's very cool. Yeah, using struct enum. I guess enum is really cool. Now things are getting a little bit more complicated, but it's more fun, and controlling the flow and everything is cool. What time is it actually? Do I want to move forward? So today is Sunday actually. I may want to end today a little bit early. How long have I been streaming actually? Do I have a clock? Oh no, I haven't been. Oh, it's only like 40 something minutes. It's not even an hour. Okay. But chapter 7 looks really big. Look at it here. I can pull it out. Look at here. It's really big. I don't know if I can go through it quick enough, or I'll get super tired. Imagine growing project with packages, create. Yeah, this is a different thing. This is like kind of package management and things. I think I may not want to dive through it today. So today we already go through chapter 4, 5, and 6, which is good, I think. Yeah, I may do it tomorrow morning. I'm not working tomorrow. I don't have a job at the moment, so which is cool. So yeah, I think what I'll do is that I will continue tomorrow. Maybe tomorrow morning. I hope I wake up like at a civilized time and then do a little bit of Rust learning, maybe go for chapter 7 before I kick off my day with other things I have to do. So yeah, I think that's it for me. Thank you so much for coming in and joining me and giving me tips. That's really helpful. I feel really supported that we are learning it together. Or actually I'm learning it and someone is like holding my hand. It feels really reassuring. It's really good. Thank you so much. And so yeah, tomorrow we'll continue, and I'm so excited to learn more Rust. It's so cool so far. I'm enjoying it. I like it. It's really good to know. Yeah, so thank you so much for helping me, and let's do this again at another time. So have a good rest of your day, no matter where you are. So enjoy, and I will see you less than 24 hours. That's what I promise. Okay, see you. Bye.